we were talking about the Borda count election system and also the Condorcet system. So could we just refresh our memories before we talk a little bit more about these things? Condorcet's method and the Borda count. I hope you remember. If not, it'll come back to you. Let's try to do each of those two methods on this made-up example, which I just made up as I entered the class today. So let's try the Condorcet method. This is the one which involves pairing up the candidates one-on-one and seeing who would win in each individual comparison. So I got to do A versus B, A versus C, and also B versus C. Those are all the ways that I could pair them up one-on-one. And we count up how many votes for A, how many votes for B. Now, I just made this up. I didn't do it ahead of time, so we might get... I don't know what the answer is going to be. But looking only at A versus B. So I look in each column here, and I'm counting up on how many times is the A above the B versus how many times is the B above the A. I see A above the B here. That's 4 people said A above B. And then also, these people put A above B, but not the ones in the middle, right? So how many people put A above B? I would say 4 here. Plus another 3, that's 7 people prefer A above B. I hope you remember how to do these. And then it's only the people in the middle who like B better than A. That's 2 people. And so A is the winner of this comparison. Between A and B, A is the winner. All right? What about A versus C? How many people like A better than C? I see 4 people here, not them, and yes, them. So again, this is 4 people plus another 3 people like A better than C. So 7 people like A better. C, only 2 people like C better. Actually, I can tell at this point that A is the Condorcet winner. A wins every comparison involving A. You don't even need to do the last one, but just for the sake of completeness, just so that we all know what we're doing here. When you compare B versus C, can somebody shout it out, how many people like B better? 4, yeah. These people have B above C. The other 2 have C above B. So 4 people, and then the other 5 like C better. So C is the winner in that comparison, but it wasn't enough to win in Condorcet's method. A wins. All right. I hope you all remember this. I'm just trying to refresh your memory here. We're going to do some more bigger examples in a moment. All right. Great, and let's try the Borda. That's actually what we were in the middle of talking about at the end last time, is the Borda. So can we try the Borda? I'm going to just copy this down here. The Borda is the one when you add up points, and the points are always arranged like this. You get 0 points for a last place vote. Then 1 point for 1 position up, 2 points, 3 points, etc. Here it's just 0, 1s, and 2s. All right, and when you're doing the Borda, you have to add and multiply the points. This is really the only one in which you need to do multiplications. A, how many points did A get? Well, in this position, A gets 2 points, but there were 4 people who put them there, so that's actually 4 times 2 right here. And then in the next column, A got 0 points from 2 people, so that's plus 2 times 0, which is 0, of course, and then plus, in the third column, A has 2 points from 3 people. That's 3 times 2. All right, this is how you think that through, and then you actually add them up. Remember, you have to multiply first and then add, so this is 8 plus 0 plus 6, which is 14, like that. This is how you do the Borda count. I hope that makes sense. This one is the most, I suppose, the most like numerically intensive. It's just a bunch of adding and multiplying. All right, how about B? Same idea. B has 4 people giving 1 point each in the first column, so that's a 4 times a 1. Plus the second column is also 1 point, so that's a 2 times a 1. plus the last column is a 0, so that's a 3 times a 0. This adds up to 4 plus 2 plus 0, that's 6 points for B. And then C is going to be a 4 times 0 plus a 2 times 2. That's 2 points in the middle, plus a 0 at the end. 3 times, no. What? Sorry, I'm looking at the wrong ones. That was just the last one I messed up. I still got that COVID brain fog going on. 3 times 1, like that. All right, I hope this is what you got. 0 points in the first column, 2 points in the second column from 2 people, 1 point in the last column from 3 people. So this, when I add and multiply, that's 4 plus 3, which is 7. Anyway, A is the winner with the Borda. A did much better than the other two. All right, this is how we do the Borda and the Condorcet's method. All right, I wanted you all to try, and this will be like, if you can do this example, you can do anything, because this is the biggest example that we're ever going to do. So I would like for you to try the Condorcet and the Borda for our class election. Remember that one? This I handed out a few times ago. I don't know if you still have the handout. I'm going to put it up on my screen in case, just in case you don't have it. That's this thing here. Remember that? So I would like to take a few moments. I'm going to walk around and see how everybody's doing. If you have this on paper, that's fine, or you can copy it down. Try to do the Condorcet's method here, and try to do the Borda count here. This is going to be a little annoying just because it's so big, but if you can do this one, you can do anything. This is going to be the biggest example that we ever do. All right. How about let's do the Borda first, just so that we're all doing the same thing. Remember, that's the one with the points that go like this. I'm going to walk around, just make sure that everyone is adding and multiplying properly. And this is really annoying to do all of these. How about we have C, M, P, and W? How about the people on this side of the room just do the C and the M, and the people over there do the P and the W, and then we will share our answers when we're done. See what you think. Remember to add and multiply correctly. could probably do this without copying the whole chart. You just write down the numbers, maybe good enough. Getting anywhere? I'll give you a few more minutes, then we can talk about up to one over here. 42. Yeah, I guess they are. Yeah, sorry. Too late. Okay? Yeah. Numbers. Are you ready? Yeah. Can we talk about these? It looks like most people are either done with two of them or fed up with them, maybe both. How about let's just do the C all together here. I know some of you did the C. I believe the answer is 42 as I was walking around. I didn't work these out ahead of time. But is that not what you got?
I got 36.
36. Oh, maybe maybe I'm mixing them up. Sorry, I don't know.
For M, I got 32.
Okay, let's do the C together here. So I'm going to look at the points for the C. I have C in the top position for all of these. Now you could write them all down individually. So this would say 1 times 3 plus another 1 times 3 plus 2 times 3 plus 1 times 3 plus 2 times 3 plus 1 times 3. That was all of these ones. All right, each time you multiply the number at the top times the point value, which is 3 for all of those ones. The next three are 1, 1, and 1 times 2 each time. So it's now plus 1 times 2 plus 1 times 2 plus 1 times 2. Now I'm writing all this out. You might be able to do some of this in your head as you go, which is fine if you want to do it that way. Next I have this position is a 1 times a 1. The next is down here, that's 2 times 0. The next is here, that's a 1 times a 1. 1 times 1. Then I see another 0. 2 times 0, and then another 1 times 1, and then now I'm right here. Another 2 times 0, then a 3 times a 1, then a 2 times a 0. Can I ignore the zeros and just go 3 times a 1? I believe I have all of them here. All right, and now you just need to multiply them all and then add everything together. This will be 3 plus 3 plus 6 plus 3 plus 6 plus 3 plus... This is what everybody thinks a college math class is all about. Just a whole bunch of nonsense adding and multiplying. That's not really what a college math class is about, although it is right now in this time and place. All right, and now add all of this together. 3 and 3 is 6. That's 12. That's 15. 21. 24. 26. 28. 30. 31. 32. 35. Does anybody agree? No.
35?
I got 30. I think I got 35 when I added these up. Did everybody get 36?
I got 36.
Who got 36? I see a lot of... Okay. So this is 36. I think I did it wrong. If you all said 36 and I got 35. I probably added these numbers incorrectly at some point. But I hope that if you did it correctly, if you all agree it's 36, then I'm going to go with 36. All right? That was the C. At least I set it up properly at the beginning. Did anybody have any questions about how I set this up? Yeah?
In general, if we have a question in the exam and everything's right except the result, maybe because we didn't count right or something, do we then have 0 points for that, or do you also look on the way how we are getting there?
Yeah, when I'm grading, I care about how you are doing the problem, not necessarily, like, for instance, if you add all these numbers up and you get something that's off by a little bit, then I don't really care about that. So I would be, if, for example, in this one, you wrote down something like this and then added up to 35 or something, I would give you credit for that. Yeah?
Do you ever have to write the numbers like times 0, or can those just be left out?
Yeah, you could leave that out entirely. I'm trying to include them just so that it's clear how I got my answer, but if you want to skip the zeros, that's fine with me. Yeah. All right. Great. I hope that this is clear how this is supposed to be done. Maybe I could just poll the audience about the other ones then. So, what did you get for M?
32.
32. Anybody else agree?
I got 35, but I miscounted.
35.
31.
31. They're all disagreeing about the M. All right, let's do the M together, and then I really won't do any more because I'm not any more likely to get this correct than you are. How about to do the M's?
Criticisms of the board account that it's easy to screw up.
I would say not really. Like the board account it is easy to screw up if you're doing this by hand, but in the real world, nobody does this by hand anyway. Right? You use a computer to do this in real life. Here's an easier one to do a big example like this. I wouldn't always expect you to do it this way, but check this out. If I'm looking at just the M's, I can see 2 M's in the 3-point position, right? So I'm going to try and just like combine together the columns as I go, which is much easier than writing all of this stuff out. 2 M's in the top position, so I'm going to say that looks like 2 3-pointers. Sorry, my colors here. I have 2 voters who put M in the 3-point position, right? How many people put M in the second position? That would be 1, 2, 3, 4, 5. I count this twice because there's 2 of them. 6, 7, 8. 8 people put M in the 2-point position, all right? As I was walking around, I think I saw a few people doing it this way, which is a nice way to do it. If you have a giant chart and you don't want to add up all the little numbers, it's likely you're going to mess it up, like I demonstrated. And then the 1-point position. So how many people put M in this row? 2 people here, another 2, that's 4. Another 1, that's 5. Another 2, that's 7. And another 2, that's 9. 9 voters put M in the 1-point position. And then I don't even care about counting up the 0-point voters because it doesn't matter how many people put the M in the 0 plus, times 0, right? That ends up not mattering. So this is 6 plus 16 plus 9, which is
That's 31.
31. I think that this is correct. Now, I might have messed it up again, but I think it's 31. All right? Can I just poll the audience just for the sake of seeing like a real answer here? What did you all get for the P?
It's 42.
42? Anybody else agree? Yes. All right. And the W?
41.
41. Anybody? Yeah. All right. Great. So it seems that the winner using the Borda is the P. Pineapple, right? Mm-hmm. Okay. This is the Borda. This is the biggest and nastiest Borda example you will ever do. Ordinarily, it'll be much smaller. Like on our test, I definitely would not ask you to do one like this. It will be much smaller, and you'll just add and multiply a few numbers together. All right? Any thoughts about that? This is the Borda. All right, I would like to do the Condorcet. Now, this also is going to be big and nasty. Maybe we could just do 2 of the comparisons together rather than doing all. There's really many comparisons you have to make if you really want to do the whole thing. Let's try in the Condorcet. Let's try C versus M. All right, so I'm going to look on my chart here and ask how many of these people put C above M? How many people put C below M? So maybe I'll go across the chart just looking at when is the C above the M. I actually lined up all the C's on top here. So in all of these, the C is above the M. That's 1 here. Another 1, that's 2. Another 2, that's 4, 5, 6, 7 people here put C above M. And I think more also, not this one, not this one. This one here, so now it's 8. It used to be 7, now I've counted 8. Not that one, not that one. This one here, C above M, so that's 9. Not that one, not that one, not that one. This one here has C above M. It was 9, so now it's 12. And not that one. So this is 12 putting C above. I hope that everybody sees how I counted that. This is much bigger than a typical example that I'm going to ask you to do. And how many people put M above C? I go look through again here, this time looking for the ones which have M on top of the C. None of these do because they all have C on top. Here I have 1, 2, not that one. This one is 3, 4, 5, because that's a 2. Not here. Here is 6, 7, 8, 9, 10, 11, 12. I believe this is 12 also. Can you believe that? Is it really?
Isn't C now 13?
Is it 13?
I think C is 13 because all in all it's 25.
There are 25 total? All right. I believe them. They're telling me I did it wrong. It's easy to mess it up as I keep on demonstrating. So in this comparison, M is the winner. All right? This is how you would have to do the Condorcet. Now, if you really wanted to do the whole thing, you also do all the other comparisons. I don't really want to go through all of that business. I think I'm content to leave it at that. Anybody have any thoughts about this? This is Condorcet's method on a giant nightmare example. All right. Great. I am ready to move on to talk about something else for a little bit. So far we've talked about 4 different voting methods, right? We had the plurality system. That's the easiest one, in which all you care about is the rankings in the first position, right? That's called the plurality system. Then there's the ranked choice, which involves doing some rounds with eliminations. Then there's the Condorcet, which is all about the individual pairings. And then there's the Borda, which is adding up the points. All right, these are the 4 major systems that we're going to be talking about. I would like to, sorry, I'm I'm on a different page here. I'm going to go back to my other notes. Yes. I would like to talk about the general question, which we're going to spend quite some time discussing, is which system is better? And as I have alluded to in the past, there is no one simple answer to this question. If somebody tells you like ranked choice is the best voting system possible, that person is either lying or doesn't know what they're talking about. There is no simple answer to the question of which of these voting systems is the best. Just because there's no simple way to compare them. You have to ask yourself, well, what exactly do I mean by better? What counts as being a good system versus a bad system? And there are many ways that you could try to formulate that way of thinking, right? There are many ways that you could judge one as being good or bad and compare it to another one. So actually, we'll discuss several criteria. So when you look back, a few weeks from now, and when you look back at your notes for what we've done so far, you will see kind of two basic bunches of stuff. First, we talked about what are the different voting systems, and we have these 4 different examples. And then we're going to talk quite a bit about criteria for judging one versus another, all right? We're going to discuss several criteria for judging which are better. I will just say, actually, it's more like judging which are good or bad. What we're going to end up with is several different ways that you could try to ask. And we're going to say, well, the ranked choice is good in this and this and this way, but it's bad in this and this and this way. And the plurality is good in this way, but it's bad in this way. That kind of thing is where we're going with this, all right? Criteria for judging which are good and bad. And there are many ways that you could think of doing this. So we're going to start today by talking about one fairly simple criterion. The first criterion says, basically, I'm going to put this in quotes, or I'll put this in parentheses. This is not, we're going to have a more technical definition in a moment, but the basic idea here is that if most of the people agree who's best, then they should actually win. Right? Certainly a good system should behave in this way, where in the real world, if you actually have a scenario in which most of the voters agree on who the best person is, then that person should actually win the election, all right? This is one way of judging whether a system is any good or not, is this criterion here. And this is called, the technical name for this is called the majority criterion. And this is one way that you can discuss how good a system is. It's called the majority criterion. That word criterion just means like a specific way of judging how good something is. The majority criterion. It says, this is a very specific technical way of telling if a system is working well or not. If there is a candidate ranked in the first place by a majority of voters. Majority, remember, means more than 50%, right? Majority doesn't just mean they got the most votes. It means they got more than half of the voters, all right? Anyway, if there is a candidate ranked first place by a majority, then that candidate should win. All right, I hope that everybody agrees this is how democracy is supposed to work, where if there is a candidate who is ranked first place by a majority of the voters, then that person should end up being the winner of the election, all right? But we can think about our four different systems, the plurality, the ranked choice, the Condorcet, and the Borda. Do they actually obey this property? Do they actually function in this way? Where in the real world, say if you're using the Borda, is it really true that if somebody is ranked first choice by a majority, then they automatically win using the Borda or whatever else, all right? So our question is going to be, which of our systems actually satisfy this property? Right? If it turns out that like the ranked choice doesn't satisfy this, then that means the ranked choice is worse than the other ones, at least in this particular way of judging it, right? That's the idea here. And we're going to talk about eventually, 4, 5, 6 different criteria for judging how good our voting systems are, all right? This is the majority criterion. Which of our systems satisfy this property? Well, I would like to talk about just sort of in general, this is a typical like test question or homework question. I would ask you something like, does the ranked choice satisfy the majority criterion? And you have to explain to me either, yes it does, or explain to me why it doesn't. So to show something, to show a certain system satisfies this, and you should expect to see a question like this on our test, for example. One of the topics is the majority criterion. I don't remember what number that was, but I will ask you to show that one of our systems satisfies the majority. You have to give me a little logical argument, and it basically, I don't want to put words into your mouth, but when you are writing a logical argument about the majority criterion, it basically always looks the same way. You say something like, imagine a majority of voters put X in the first position, and then something, 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 something. You say some stuff in here, and then you say, thus X wins the election. And in here is explanation specific to Borda or RCV or whatever. So if I say something like, explain to me why the ranked choice satisfies the majority, you say, okay, let's imagine that a majority of voters put X in the top position, and then somehow, if it's ranked choice you're looking at, somehow you explain in terms of the rounds or whatever. You have to say something specific about the way the ranked choice works. And then explain to me why X is the winner of the election overall. All right, this is the idea. For example, let's try to do one like this, and then I would like you all to try to do one. How about, this is the format though that you should always structure your, I suppose what you're doing is a little proof, although it's very little, not very technical. For example, let's demonstrate that. I would like to show that plurality satisfies the majority criterion. All right. So you're going to have to write some sentences, all right? Your answer is not going to involve an example where you add and multiply numbers or anything like that. No, everything you're going to do is just written in ordinary sentences. You have to say something like, imagine that X is ranked first by a majority of voters. This is really sort of a fill in the blanks. Then you're going to say something in the middle, and then you conclude by saying, thus X wins the election. Using plurality. All right. Anybody want to try and fill in the middle here? It should be fairly, obvious if you are thinking properly. Yeah, what do you think?
Imagine X is ranked first by a majority of voters due to the fact that the most first place votes win in the plurality system. X wins the election using plurality.
Yeah, it's because they got the most votes, more than anybody else. And how do you know they got more than anybody else?
They're ranked. They got a majority.
Because they got a majority in the first place. And you can't have somebody else get a bigger majority. Majority means more than 50%, right? So you can't have one person got a majority and somebody else got an even harder majority. There's no such thing as a even harder majority, right? If one candidate gets a majority of the first place ranks, then they automatically got the most, all right? And that means they are the winner. So you got to write something like that. Now, probably you can just write this in one sentence if you say your words properly. Think about what you're saying. You don't have to ramble on here, but I would say something like, then X gets more first place ranks than anybody else. And thus X wins the election using plurality. Because that's what plurality means. It is whoever got the most first place rankings. So if somebody got a majority, then that means they got more than everybody else. And so they are the winner using the plurality system. All right? I don't know if this seems sort of easy or obvious to you. I think you will find when it comes to trying to write down these little arguments, it is not, perhaps not as easy as it seems. Or maybe it is, I don't know. If you like math problems where you just add some stuff together, this is not that. This is math problems where you have to actually think about something and explain yourself clearly. All right? I would like for you all to try one, and I'm going to walk around and see what I think. It's the same exact structure, and again, you basically just have to fill in one sentence in the middle. Do the same thing, but for Condorcet's method. So I would like you to show that Condorcet's method satisfies the majority criterion. Show that Condorcet's method satisfies the majority. All right. Try that. Okay, maybe I'll try and keep this all on the same page. I can't quite. Structurally, you should say it the same way. So you can start by saying, you don't, like I said, I'm not trying to make you say exactly the same words as I do, but I think the structure helps you to think about it. Imagine that X is ranked first place by a majority of voters. This time you have to explain why they win using the Condorcet method, which is a totally different method, so it's going to be a totally different reason why they're going to be the winner. But that's what I would like you to think about. I'll walk around and see what you think.
So this is using the cheese maple syrup.
No, we're not talking about any example in particular. You have to imagine any possible election where X gets more first place or gets a majority of first place rankings, and then explain why they are going to be the winner using the Condorcet. You have to think about what makes the Condorcet winner. Like, how do you decide who the winner is? And is such a person really going to be the winner? your thing that you say in the middle better mention pairwise comparisons. If you don't mention comparisons in pairs, then you're probably not doing it right, because you're supposed to be talking about conversation method. It's all about that. All right.
Yeah, that's right.
Okay. All right.
Yeah, that's great.
All right. Okay. All right.
Yeah, like, how would you, like, break that, like, explain why, like, they went due to political affairs and the outlier?
Yeah. So if they're ranked in the first position, I think that means that every time you pair them somebody else, if they're ranked on top of the majority of the time, they have to win against them.
Okay.
So you can't say something like that.
Alright.
All right, can we chat about it? As I was walking around, it looked pretty good to me. As I said, you must say something about the pairwise comparisons. If you didn't mention comparing in pairs, then you're not talking about Condorcet's method, and so you're not talking about the majority criterion. As I was walking around, I saw a lot of people with good answers. I would have said something like, then X wins in any one-on-one comparison. Right? That's because if they are in the top position by a majority, then every time you compare them individually, it's still true that a majority of the voters likes them the best. And so then X is going to win in any one-on-one comparison. I mean, that's all that you have to say, really. And then that means that X is the winner overall using Condorcet's method. All right? So the Condorcet method does satisfy the majority criterion. All right? You should expect to see a question like this on the test about the majority criterion. Can we talk about the Borda? The Borda actually, it turns out, the Borda does not satisfy this criterion. I don't know if you were expecting that. The Borda does not satisfy. So can we just talk briefly about how to show something doesn't satisfy the majority is what we're talking about in this case, although we're going to talk about several other criteria as we go. How to show something doesn't satisfy the majority? Well, for this, actually, you would use a specific example. To show that it does satisfy the majority, you have to somehow logically explain why. If somebody's in the top position a majority of the time, then they're going to be the winner. But the other way around, it just means it's possible that they're in the top position, but they still lose. All right. So to show something doesn't satisfy the majority, you need to find or invent an example. Maybe you can look through your notes if this is a homework question or something. Find or invent an example where some candidate is first place on a majority of ballots, but loses the election. Right? And if that is possible, if it's possible for that to happen, that means automatically the majority criterion is violated. So if you want to show that it is not satisfied, you use a specific example. If you want to show that it is satisfied, it's not good enough to just show it on one specific example. You have to show it in all possible cases. But to show that it's not satisfied, all it takes is one example. All right? So can we do this for the Borda? So Borda, it is a fact, Borda does not satisfy the majority criterion. All right? Why not? You know, these examples can be difficult to cook up, and when it comes to our test questions or something, it's not. I'm not going to ask you to invent on the fly some kind of complicated example. Do you have an idea or a question?
Yeah. A candidate could get a majority of like first place votes, but every single other place could be the last place vote or zero. So
Yeah, right.
that's when the zeros come in.
Yeah, if you think about the way the Borda works with the points, it should seem to you at least plausible that maybe somebody could be first place by a majority, but total like dead last otherwise, and then maybe somebody else is in like second place the whole time, and somehow their second place votes add up and make them the winner, even though the person who was on top, they were on top, but they're going to get less points overall. That's what the example is going to look like. So actually, here is a cooked up example that's just like that. And you could come up with this if I gave you enough time to play around with the numbers, but here is an example. All right, so you can see in this example, A is ranked first place by a majority of the voters. That is 3 out of 5, right? There's 5 voters here, and 3 of them put A in the top. But like she said, I put A in the bottom for the other voters, and you will see B actually has a strong showing both times. And if you add up the points, you will see this actually allows B to get more points than A. So what if we actually add up the points? I'm confident that I can do this without messing it up. The points go 0, 1, 2 like this. So A gets 3 times 2 plus 2 times 0, that's 6. B gets 3 times 1 plus 2 times 2, that's 7. And C is not going to win, but just for the sake of doing it, C gets 2 points. Anyway, B is the winner. All right. So this example demonstrates that the Borda does not satisfy the majority criterion. All right. All it takes is one example to show that it is not satisfied. If you want to show it is satisfied, you need to argue logically. You can't just show a particular example. Okay, so A, can I just summarizing the important point here, A was ranked first by a majority, but A lost using Borda. This cannot happen using plurality or Condorcet's method, but it can happen with Borda. All right. So that means the way that we say that is Borda does not satisfy the majority criterion. All right. And this is a bad thing about the Borda. This is one reason why you might not want to use Borda in the real world. Now, you have to think to yourself, how important really is this to you if it comes to voting systems in the real world? But you can say this, next time someone asks you, hey, what's so bad about the Borda? You can say, well, the Borda doesn't satisfy the majority criterion. This is the way that people talk about these things. All right? And your friend will say, oh, yeah, well, but Borda does satisfy the monotonicity criterion, which it does. That's another one that we're going to talk about. So we're going to talk about several different criteria. All right? The Borda does not satisfy the majority. We're going to make sort of a big chart here, which we're going to be adding on to each day as we go along. But this is going to be about our voting systems here. I'll write plurality, the ranked choice, the Condorcet, and the Borda. Right? And then we're going to have several columns. So you might want to like find a page on your notes where you can make a big chart like this. We're going to be adding on to it. We're not going to add a lot more rows, but we are going to add several more columns. And what we've demonstrated so far is plurality. I'm going to put a nice little green check mark. Plurality and the Condorcet, they do satisfy the majority criterion. The Borda does not. So what we're looking for here in terms of finding like the best system is we want a system which has a lot of green checks. That would be a good one. And one which has a lot of red X's, that would be a bad one. All right, or at least a less good one. I'm not really saying, this doesn't necessarily mean the Borda is terrible. It just means that in this one particular way, the Borda is not as good as the others. All right? And what about the ranked choice? Actually, this is going to be one of the homework problems, but I'm going to ask you to explain on the ranked choice, or on the homework, why the ranked choice does satisfy the majority. So you can put a check in the chart there, although we didn't do that part yet. But this is going to be one of the homework questions. Explain why the ranked choice does satisfy the majority criterion. All right? Great. So this is sort of where we're going for the next few times here. Let's talk about, how about another column here? Might as well go for it. All right. Another one, actually the next column is sort of regarded as a very easy one to satisfy, or very low bar. This is called the unanimity. Unanimity. This is like majority, only it's about when the voters are actually unanimous about their opinion. If the voters are actually unanimous, then the answer of the result of the election should follow what all the voters said. That's the idea behind the unanimity criterion. Let's talk about that next. Unanimity criterion.
Is it possible for a voting system to not fulfill this?
It is, yeah. Although, so I have to say technically exactly what I mean by unanimity. Although, if a system doesn't satisfy unanimity, then that's like, to me, that's a major red flag. Like basically, because the unanimity criterion is a very low bar in terms of a good system ought to satisfy this property. So here's what the unanimity criterion says. It says, if all voters, this is why it's called unanimity, because it's about all of the voters. If all of the voters rank somebody X above somebody else Y, actually every single voter puts X above Y, then, anybody want to suggest what I should say here? Well, like what should actually happen? This is a bit of a trick question. I was hoping somebody would say, then X should win.
Yes.
Yeah, actually that is not what the unanimity criterion says. It says instead, then Y should not win. If all the voters rank X above Y, then Y should not be the winner. This is what the unanimity criterion says. Now, what's the difference? Why? I just said it's actually, don't write then X should win. The difference is that there could be more than two options on the ballot, like most of the elections we're doing have more than two options. And it could be that if everybody likes X more than Y, then maybe they also like, say, Z more than X. There's somebody else who they like even more. Then the Z should win, not the X. The point is the person who's below on everybody's opinion should not win the election. Yeah.
So it's like in ranked choice voting, if X has more than Y, but then Z gets eliminated and all those votes go to X. and then they, or it goes to y and y to go next time.
Yeah, something like that. Yeah. Just because X has more votes than Y doesn't mean that X should be the winner. It just means that Y should not be the winner because there might be somebody else who has even more votes. Right? That's the idea behind this. Y should not win. So I'm just going to say this is a very very commonly misunderstood or misremembered. It doesn't mean X should win. It just means that Y is not going to be the winner. All right. Anyway, this is called the unanimity criterion. Can we let's again let's try an example. How about the plurality system? Show that plurality satisfies unanimity. All right. How do we do that? Well, you should write your argument with the same kind of structure. Now, it's not going to say, imagine that, like before, imagine that X is ranked first choice by a majority. That's the majority criterion. How do we do it for the unanimity criterion is, I say, imagine all voters rank X above Y. All right? And then fill in the blank somehow. And I have to conclude by saying, thus, Y doesn't win with the plurality, because I'm talking about specifically plurality in this example. All right. Imagine everybody ranks X above Y, and you have to explain why does that mean that Y is not the winner using the plurality system. Anybody, any thoughts? What do you think? If it's true that everybody puts X above Y, anybody else want to say? Anybody else? Yeah?
So y wouldn't have any first place votes.
Yeah, I like this. Plurality, remember, is all about first place votes. So how many times when you count up the votes of how many people put X in the top, how many people put Y in the top, how many people did put Y in the top? The answer is 0, because everybody prefers X above Y. All right? So if all voters rank X above Y, then Y gets 0 first place votes. Thus, Y doesn't win with plurality. There you go. All right. I hope you agree. Like I said before, I would not expect you to write a whole lot of stuff. You probably just have to write 1 or 2 sentences if you say them correctly. If you end up writing a whole big paragraph, you're probably not doing it the best way, all right? Although it may not be wrong, okay? If all voters rank X above Y, then Y gets 0 first place votes. All right? Could I ask you all to try? How about, can you explain why the ranked choice satisfies the unanimity? Anyway, I'm going to put a check, the plurality here. The ranked choice, can we do that one? I'll give you a moment to think about it. This time, when you make your explanation in the middle, you better say something about rounds or eliminations or something like that, because that's what the ranked choice is all about. I'll give you a moment to think about it, and then we can talk about them. give you till the clock says 1:35. Actually, I'll give you till right now, because there's one more thing I want to say, and we got to go in 10 minutes. What do you think? Anybody want to volunteer? Maybe somebody who hasn't told me an answer yet? I appreciate your enthusiasm. What do you think? Yes? I like this a lot. Thank you. Yeah, if everybody likes X more than Y, then you can be guaranteed that Y will be eliminated before X, right? At some point, X is going to have more votes than Y. In fact, Y, actually I can say Y will be eliminated, if you think about it, I think Y gets eliminated in the first round, because when you count up their votes, they have no votes in the first position. But in any case, Y is eliminated before X. Is that
I'm gonna say technically the first round, because if there's 3 choices and you have like X, Y, and Z, and Z has lower than Z would get eliminated first and then Y, but X would still win. Y still wouldn't win, but they could still be the second lowest.
I think Y cannot make it through the first round, because this is all kind of a technicality, but when you're counting up the votes in the ranked choice, you count how many times was X put on top, how many times was Y put on top. Y was put on top 0 times.
Okay, I was thinking more like if there was like a 3-choice thing, if there was X, Y, and Z. X could be put on top first, Y could be only in second, and then Z could be in third. And Z would get eliminated first, then Y, then X.
It wouldn't happen that way, because when you count up, when you're doing the ranked choice, you look at like round 1, right?
Oh, wait, yeah, never mind. Yeah.
And you say X, Y, Z. Y would automatically have 0. And so maybe Z also has 0, in which case they're both eliminated. But anyway, all of this is just kind of details. Really, all that's necessary is to say that then Y is eliminated before X. All right? Really, Y will be eliminated immediately at the very beginning, but that's just a detail. If everybody likes X more than Y, then Y will be eliminated before X, and so X does not win using the ranked choice voting. Yeah, excellent. This is the unanimity property. The ranked choice does satisfy the unanimity, and I'm just scrolling back up to the chart. So there should be a check here. And the other two I'm going to ask for you to explain on the homework also. The other two actually end up both being checks also. So these two are also checks. Those two I'm going to put on the homework. All right. Now we have 8 minutes remaining. That actually is enough to talk about one more column here. And this is has a big name to it, but it's very simple. I'm going to call this the CWC. That is called the Condorcet-Winner criterion. The Condorcet-Winner criterion. What this means is that this is about Condorcet winners. If you recall, I don't know if you remember this bit of terminology, but if one of the candidates wins all of their comparisons against all of the other opponents in one-on-one comparisons, that's called the Condorcet winner. So a Condorcet winner is one who would win in any one-on-one comparison, right? And the Condorcet winner criterion, this is called CWC. That means if there is a Condorcet winner, somebody who would win in all the one-on-one comparisons, then that person should win the election. All right? So that's what the Condorcet winner criterion says. So here's the definition. A system satisfies the CWC when if there is a Condorcet winner, that is somebody who would have won in any comparison against all of their other opponents. If there is a Condorcet winner, then they win the election. All right. So CWC means when there is a Condorcet winner, that person ends up being the winner of the election. All right. This one is easy enough to just look at the chart and immediately say X's and checks. So the easiest one is the Condorcet method does satisfy the Condorcet criterion, because that's the whole point of the Condorcet method, is that you find the Condorcet winner and you make them the winner of the election. That's what the Condorcet method is all about. But the other ones are a little more interesting. What about the plurality, for example? In the plurality system, if there is a Condorcet winner, is it guaranteed that they are going to be the winners of the election? Do you have any thoughts about that? Is it possible for somebody to be a Condorcet winner but still lose the election if it's the plurality? Condorcet winner, remember, means they would win in any one-on-one comparison. I think actually it is possible for a Condorcet winner to lose an election with the plurality. This actually happened with the Bush-Gore nadir. Gore would have won in any one-on-one comparison. If it was just Gore versus Bush, then Gore would have won, and just Gore versus Nader, then Gore would have won. But because we used the plurality, actually Gore did not win, right? The Bush won. So there's an X here. I'm going to try and write in words why that X is there. So come on. What I just X'd was plurality does not satisfy the Condorcet winner criterion. That's because there are examples, for instance, the Bush-Gore nadir. It is possible for someone to be a Condorcet winner, but plurality loser. Like dear Mr. Gore was the Condorcet winner of that election, but he was the plurality loser and real-life loser of the real-life election, all right? This means the plurality system does not satisfy the Condorcet winner criterion. This, in my opinion, is a big bit of bad news for the plurality system. Sometimes there is a Condorcet winner, but they end up losing in the plurality system. All right. This happened also in the election example that I handed out with the ABCD on the first day of class. In that election, the plurality winner, I believe, was A, but the Condorcet winner was C, I think. I don't remember the details of that. In that same election, you will recall that the ranked choice was also different from the Condorcet. It turns out that can happen also. The ranked choice winner is often different from the Condorcet winner. All right? This can happen sometimes. This is a bit of bad news about the ranked choice. And I'm also just going to tell you, just because it's about time to go, the Borda also does not satisfy the Condorcet winner. It's possible for somebody to be the winner with Borda. It's possible for somebody to be the winner with Condorcet, even if they lose with the Borda.